Okay, so in this question, they give us a graph. And before we start reading the questions, it's always a good idea to read the description and then look at the graph to make sure that we understand what is going on. So in this question, it says that Sam collected data by measuring the pencils of her classmates. So clearly they're talking about a traditional pencil, like a yellow pencil okay. She recorded the length of the painted part of each pencil, right, and the weight. So, I'm not an expert at drawing a pencil, right, but if this is the pencil, right, and then this is the kind of the sharpened part, there's no paint on this part, right? This is the sharpened part, it's ground. So she measured, right, this painted part here, and then she weighed the pencil. So clearly, the longer the painted part, the more the pencil is going to weigh. The shorter the painted part, the less it's going to weigh. However, when the painted part is completely gone, if that were possible, right, the pencil would still weigh something because it would still have that non-painted part that you grind down at the tip, right? Okay, so now we understand that. Now let's look at the graph itself, right? So the x-axis is the length of the pencil, and the y-axis is the weight. So clearly, as the length increases this way, the weight, increases, which makes sense. The longer the pencil, the more it weighs. Okay, so now it says for A, describe the association, right? Describe the association between weight and length of the pencil. Remember to describe the form, the direction, the strength, and the outliers. Okay, so look at this graph. These points are so tightly coupled in here. Right? So we would say that this is strong, right? Because they're so tightly coupled in there, right? It's also in the shape of a line, right? So we would say it's linear, right? Clearly I drew a line through it, so it's linear, right? And then it goes uphill from left to right, right? Because graphs that go uphill from left to right are considered positive correlation, and graphs that go downhill from left to right are considered negative correlation, right? So this case, it's clearly going uphill, so we would say it is positive, right? Positive, right? Association, right? Or correlation. Association, and I'm going to write correlation under here because correlation is probably the more typically used math term. And then outliers. Well, clearly, looking at this graph, right, there's an outlier right here. So how do we describe that outlier, right? We could do it by the weight. We could say the outlier is, what is that? 4.5. Looks like about 4.5, right? We could say there's an outlier, right? One outlier. At about 4.5 grams, or we could say there's one outlier at about 2.1 centimeters, right? You could use the length to show where it is or the weight, right? You're just giving an estimate there, right? Okay, so we tackled A. Now it says B, make a conjecture, which is just a guess, kind of an educated guess, about why Sam's data had an outlier. Okay, so let's look at the coordinates of that outlier, right? The coordinates are about 2.1, right? 2.1, and 4.5. I'm guessing that's about 4.5, right? This is this point right here. So 2.1, 4.5. If I took a look at 4.5, let's say, one of the most common mistakes when graphing is you flip the x and the y. So let's say I used the 4.5 here, and I graph that as x, that would be about here, right? And then 2.1 is about here, right? And that would kind of be in line with the graph. So I'm going to say, as my guess, she reversed the x and y, the weight and the length. That's my guess, right? I mean, you could just say she measured wrong, but I mean, this seems like more appropriate of a guess. Okay, so now Sam created a line of best fit, and they give the equation of that line in slope-intercept form, right? Where W is the weight and L is the length. Okay, what does the slope represent? Okay, so let's remember what slope means, right? Slope is the change in y over the change in x. So as x goes up, right, 1, right, from here to here, right, as the length changes, oh, that's not 1, right? As the length changes 1, right, 1 would be 6 to 7. As the length changes 1, what happens to the weight, right? So if we look at the slope here, y equals mx, she wrote it as y equals b plus mx, kind of interesting. So the slope, right, the slope is 0.25, right, 0.25. So that means 0.25, the y is grams over 1 centimeter. So I would say that, and I'm not going to write it, I'm out of room, but I would say that the slope represents that the weight of the pencil changes 0.25 grams for every centimeter that the length changes, right? Okay, and then D says Sam's teacher has a pencil. So let me make some space here, right? Let's get rid of this stuff down here. And it says Sam's teacher has a pencil with 11.5 centimeters of paint. Predict the weight of the teacher's pencil. So we can use the equation, right? So this is D, right? So the equation is W equals 1.4 plus 0.25 L, but they gave us L, right? 11.5, right? They gave us L. So this means that the weight would be 1.4 plus, so 0.25 times 11.5, right? That's 2.875, right? Assuming I did that right. Okay. So the weight comes out to 1.4 plus 2.875. That's 4.275. So I would say approximately, right, approximately 4.275 grams, right, because we're using grams. Okay, then E says, interpret the meaning of the y-intercept in context. So remember we talked about this, right, for E. Remember that here's the pencil, here's kind of the shaved part. This does not have paint. So the y-intercept is when the length is 0, which means that we don't have this part of the pencil. None of the painted part is there. So we only have this little tip, right? So the y-intercept, we're really saying that the pencil is so short, right? There's no paint on there at all. And this tip part would weigh would weigh the y-intercept right there, right? So the tip of pencil or non-painted part would weigh 1.4 grams, which seems like it could be true.